Uh, okay, so in problem 3, we want to analyze the graph of this function to try to find the critical points, local maxima, local minima, and where the function is increasing, decreasing, and concave up, concave down. Okay, so first, part A asks to identify all the critical points for this graph. So for the critical points, we're going to focus on sort of the middle portion of the graph and ignore the two endpoints. So in the middle portion of the graph, what we're looking for in terms of the critical points are the peaks and the valleys, right? So you see in this graph, there's a peak here, there's a valley here, there's a peak here, and even though this is sort of a sharp point, this is considered a valley here, right? So I have 4 critical points, and in part A, I want to denote the x values of these points, right? So the first one here, the x value is negative 0.7. And then the second critical point here, the x value is 0. And then the third critical point here, the x value is positive 0.7. And then finally, the last critical point here, the x value is 1. Okay, so those are the critical points. And okay, so now for each of these 4 critical points, we need to determine if it's a local minimum, local maximum, or neither. Right, so here, when x is negative 0.7, that's a peak, so that this is a local max. Then at positive 0.7, it's also a peak, so that's also a local max. So we have 2 local maxes. So let's list them in part B. So this point here is a valley. However, because there's an open circle, the point itself doesn't exist. So this is going to be neither a local minimum or a local maximum. And finally here, even though this is a sharp point, the point does exist. So this is a low point, so this would be considered a local minimum. Okay, so B, C, and D is looking where the first derivative is either positive or negative. So whether the first derivative is positive or negative indicates where the graph is increasing or decreasing, right? So part C essentially is just asking where the graph is increasing, and part D is asking where the graph is decreasing, because negative derivative means the graph is decreasing. Okay, so as always, when you're looking at the graph, you should go from left to right, and increasing means the graph is going up, like this, and then decreasing means the graph is going down, like this. Okay, so, and also when it's talking about intervals, it's intervals along the x-axis, right? So we're always reading off the x values here. Okay, so it's increasing from this point to this point. So what are the x values? It's going from negative 1.2 to negative 0.7. And then this part is going downwards, so this would be decreasing. So that's, again, we're reading off the x values, right? So the x value here is negative 0.7, and then the x value here is 0. And then this portion here is going upwards, so that's increasing, and the x value is from 0 to positive 0.7. This small portion here is going downwards, so that's decreasing, and the x values is from 0.7 to 1. And then finally, this portion here is going upwards, so that's increasing, and the x value is from 1 to 1.5. Okay, so those are where it's increasing and decreasing. Okay, so next we're gonna look at inflection points and concave up, concave down. So the inflection points are essentially where it changes curvature, right? So you can see that in this region here, it's concave down, right? So the downwards, so concave down, concave up generally has this shape, and concave down generally has this shape, right? So this is up to here, from here to here, up to about here. This is the concave down shape, and then from here to here we have a concave up shape, right? So somewhere here it's changing the curvature. So let's just try to guess it. Maybe around 0.4. So here again we're just trying to approximate, right? So it doesn't have to be exact, but it should be around where it should be, right? So let's say around negative 0.4 is where it changes from concave down to concave up. So there's an inflection point at x equals negative 0.4. And then similarly, this middle portion here is the concave up shape, but here we have a concave down shape, so it changes somewhere in the middle, so around positive 0.4. And then this is a concave down shape, whereas this portion is a concave up shape. So it also has to change concavity here. So we have an inflection point at x equals 1. Okay, so the graph has 3 inflection points, and then f and g again is determining concave up and concave down. So second derivative is positive, means it's the concave up shape, and then second derivative is negative, means it's the concave down shape. Okay, so let's read off the intervals. So this is concave down. Again, the intervals are the x values, right? So from negative 1.2 to around negative 0.4. And then in the middle portion here, from negative 0.4 to positive 0.4, it's concave up. And then from 0.4 to 1, it's concave down. And then finally, this last portion here is concave up, so that it's from x equals 1 to 1.5. Okay, so these are the various features of the graph.